In this video, I'm going to look at straight line graphs. I'll start with the basics and then we'll make our way up to the top end of GCSE. So let's start from the beginning. This is the x-axis and this is the y-axis. Sometimes we'll be asked to draw horizontal and vertical lines. An example of a vertical line would be x is equal to 3 or x is equal to minus 2. We could draw these simply straight line, finding a point now. So let's start with x is equal to 3. Now x is equal to 3 just here, okay? So all we would do is draw a vertical line through that point and continue it straight through. Don't stop here, just keep it going. If we wanted to now draw x is equal to minus 2, well here's minus 2 on the corner axis, and then we would just draw it like so. And make sure you're accurate. With the computer here, it's often kind of just needs a bit of adjustment. So these now are vertical lines. X is equal to 3 and x is equal to minus 2. If we were asked to draw horizontal lines, for example, y is going to be equal to 1 or y is going to be equal to, we'll go for minus 1. Let's draw those. So these now are horizontal lines. So let's get that on. And that one will be just here. So y is going to be equal to 1, which is just here, and then y is going to be equal to minus 1. So nice and straightforward. These are simply horizontal and vertical lines. What we'll do is look at some of these in action. So this is a standard corner axis. X is equal to 3, y is equal to 2, x is equal to 4, x is equal to minus 1 and y is equal to minus 3. So all we've got now are just straight lines, horizontal and vertical. So let's remove those. The next skill that you'll be asked to do is to draw a straight line from a table of values. So let's take a straight line. A straight line might be in the form y is equal to 2x minus 1. All we need to do is draw up a table of values for x and y. So in here, what we'd have, it looks something like so. So along the top, I can choose some values. Unless I'm given them, I can choose them. 0, 1, 2, 3, and 4. So let's think about this. When x is going to be equal to 0, 2 lots of 0 minus 1 will give me minus 1. When x is going to be 1, 2 lots of 1 minus 1 will give me 1. So y will be equal to 1. When x is 2, 2 lots of 2 minus 1 is 3. So y is going to be equal to 3. When x is 3, 2 lots of 3 minus 1, that's going to give me 5. So y is going to be equal to 5. 2 lots of 4 minus 1, 7. You might notice this is going up by 2, which is the number in front of the x value. So all we need to do now is plot these points. So what we'll do, we'll find x is 0, y is equal to minus 1. Well, there's x is 0, y is equal to minus 1. Then we've got x is 1, y is 1. So that's just here, 1, 1. Then we've got x is 2, y is equal to 3, which is just here. Then we've got x is equal to 3, y is equal to 5. And then we've got x is equal to 4, y is equal to 7. All we need to do now is draw a straight line through these points. So ensuring that our graph continues off the paper, don't stop it anywhere. What we'll end up with is something looking approximately like so. So don't just draw half a line that stops somewhere on the page. This will continue for all values, and that's fairly accurate, okay? And then all we need to do now is label this y is equal to 2x minus 1. Later in the video, we'll look at the idea of the gradient and the y-intercept. In this case, the gradient is 2. We can see at any point, if we pick it up, that this is going up 2 for every one it goes across. Okay, so it's gone up 2 for every one it goes across. And all I've done is pick 2 points. You only really need two sets of values to draw a straight line. If you consider when you go fishing, I'm now assuming you do go fishing, which is incredibly, well, it's going to be incorrect for most, isn't it? If you go fishing and you put rod rests in the bank and then you put a rod on it, once you've got 2, that rod is not going to move. It can't move any other way. And this is exactly the same with straight line graphs. Once we've got 2 points, we can put it on. The more, the better. But in general, 2 points are going to see you through. So unless you're given values, you pick your values and continue it downwards. The reason I didn't choose negatives is because it can make it slightly harder. Okay, let's do another one. Let's do y is equal to 1/2 x plus 1. So again, table of values. All you'll be asked to do is a table of values. This is deemed to be a lower skill than doing it from a gradient and intercept. So what we'd have then is the following. We'd have x and y. We'll start with 0, 1, 2, 3, 4. With this problem, all I'm going to do is look at values that we can divide by 2. So half of 0 is going to be 0, plus 1 is going to be 1. I'm not going to bother with the 1. I'm now going to go to the 2. Half of 2 is 1, plus 1 is going to give me 2. I'm not going to bother with the 3, and then I'm going to do half of 4, which is 2, plus 1, which is going to give us 3. If you were asked to fill out the table of values, you must ensure that you're putting these in and take the time to work them out. But if you're not, and you're just asked to draw this straight line, you don't have to worry about these, and we will see why now. But if you're asked to fill out the table of values, put these values in. So what we're going to have then is 0, 1. Well, that's going to be just here, okay? Just think about this one. That's 0, 1. X is y. X is 0, y is 1. Then we're going to have 2, 2. Now 2, 2 is going to be just here. Then we're going to have 4, 3, which is going to be just here. We've got enough points to put a straight line through, so what we'll do is do that. And what we'll end up with now, let's make sure we get this nice and straight. It will look something, give or take, like so. And your level of accuracy will be higher than mine because you've got a pencil and paper, which of course you're going to do your graphing rather than a pen. And then we'll draw it like so. So that's the line right there, and we can state that this is going to be y is equal to 1/2 x plus 1. So make sure that you're labelling these up fully. Okay, so that's a fairly basic skill in terms of drawing straight line graphs. Other particular examples that you might be given are as follows. X, let's change that, that doesn't look too good, does it? X plus y, that's what we want. X plus y is equal to some value. So let's do x plus y is equal to 4. You can rearrange this as we did before. An alternative method now is to think about the following. If x is 0, y must be equal to 4. Okay, so if x is 0, 0 plus y is 4, y must be equal to 4. And we can plot this point just here. That's where x is equal to 0 and y is equal to 4. Now if y is equal to 0, then x must be equal to 4. So we can plot that point just here. And this is a point now 4, 0. So x is 4 and y is 0. And all we'd do is draw a straight line through them. Okay, and then what we'd see is the following. We'd end up with something looking, give or take, like so. And again, make sure you're extending this now on across the page right the way up. Don't just draw it halfway. Don't just settle with the line between the 2 points. Don't just draw it from there to there. And then all we'd need to do now is label this up, and we would say x plus y is equal to 4. Now, just be aware that that could be written in different ways. If we subtracted x from both sides, we could have y is equal to 4 minus x, or even y is equal to minus x plus 4. So recognise that these graphs can be written in different ways. So let's look at another one. Y plus x is equal to minus 3. So let's consider the following. If x is going to be, or we'll start with y, if y is going to be equal to 0, then x must be equal to minus 3. Okay, so that's that point just here. Okay, so what we're going to have is the following. So this one is going to be just here. So when y is 0, x must be equal to, don't want a white, that doesn't really work. X is going to be equal to minus 3. When x is 0, y will be equal to minus 3. So what we'll have is that point, and that's just going off my screen slightly. And then, of course, we just draw a straight line through it. So let's do that now, and it'll look something, give or take, like so. Okay, let's put it there, and then just here. It will behave. It wants to go through there, and like so. So that's that line, and hopefully you can see if you fiddle with it enough, it will, there we go. And then we simply need to label that line up. So that's y plus x is equal to minus 3. And again, that might be written in a different form. You might see this written as y is equal to minus x minus 3. Okay, so there's some basic skills. Another skill we need to be cool with is the idea of the following. We need to be cool with y is equal to x and y is equal to minus x. These are straight lines through the origin. They've got a gradient of 1. If you want to think about this now reasonably, what you're going to have is the following. If I drew a line like so, okay, now let's pick some coordinates on this. This point here is going to be, and I'm trying to, it looks fairly accurate, that point's going to be 1, 1. This point's going to be 2, 2. This point's going to be 3, 3. This point's 0, 0. This point down here is minus 1, minus 1. The y coordinates are equal to the x coordinates. So if you're asked to draw the line y is equal to x, it's a straight line. It's got a gradient of 1. We can see it's going up 1 for every one it goes across. It's going up 1 for every one it goes across, and so on. That is y is equal to x through the origin gradient of 1. As you can probably appreciate now, y is equal to minus x will just be going in the opposite direction. So we'll end up with something looking, give or take, like so. And again, we need to extend this straight on from a graph paper. So if we picked a point now, if we take 2, so when x is 2, y is minus 2. So x is 2, y is minus 2. This now is going to be y is equal to minus x. So they're nice and straightforward things to think about. If you're given y is equal to x, just remember the number in front of x is 1. This is y is equal to 1x, and this is the gradient. If you're given x, it's just one lot of that. Okay, so there's some nice straightforward examples. What we're now going to look at doing is graphing straight lines by the gradient and intercept method. The general form of a straight line is y is equal to mx plus c. M is the gradient. This right here is the gradient. And now this is the y-intercept. So this is where it's going to cross this line right here. The gradient is the change in y over the change in x. Or you might see it written as delta y over delta x. Or, less commonly, rise over run. What we're going to do is start looking at some of these examples. A nice example was the last one. Y is equal to x, and then we'd have plus 0. We wouldn't put the plus 0 on, but what this has a gradient of 1, and it's going through at 0. If we had y is equal to 2x plus 3, gradient of 2, y-intercept of 3. So it'd go through this point and have a gradient of 2. Y is equal to 1/3 x minus 1, gradient of 1/3, y-intercept of minus 1. So it'd be down here, and it'd have a gradient of 1/3. So it'd be doing something like so. Be aware that these might be written in different forms, and we'll look at that shortly. What we'll do is start off with some basics. So what we'll have, this is the line we looked at, y is equal to x. Goes straight through the origin. It's got no c value. The c value is 0, so it cuts at 0. If we had now, for example, y is 2x, gradient of 2, we can see this is going up 2 for every one it goes across. Just pick a point that it goes through where these points on the axis cross. So just find a point. So pick that point. It goes up 2 for every one it goes across, and then it's through another part there. This one, it goes up 1 for every one it goes across. So this is y is equal to x, y is equal to 2x. On this one, we're going to have now y is equal to 3x. We can see it goes up 3 for every one it goes across. It goes up 3 for every one it goes across. This next one, what's this one? Y is equal to 1/2 x. So this goes up 1 for every 2 it goes across. So the change in y is 1 for the change in x, which is 2. The next one, we've got y is equal to minus x. This goes down 1 for every one it goes across. Goes down 1 for every one it goes across. So the gradient is minus 1/1. If we look at another one, what we've got here is y is equal to minus 2x. It goes down 2 for everyone it goes across. So y is equal to 1/2 x, y is equal to x or 1x, y is equal to 2x, y is equal to 3x, y is equal to minus 2x, and y is equal to minus x. All of these have a c value of 0 as they're cutting the y-axis at 0. So that's what we end up with. So for example now, with our idea of y is equal to x, if you want to think about this, y is equal to 1 over 1x, which of course is y is equal to 1x, which we just write as y is equal to x. When we looked at, for example, y is equal to 1/2 x, this is the change in y over the change in x. It's going up 1 for every 2 it's going across. Y is equal to 3x. If you wrote this as a fraction, it'd be 3 over 1. It goes up 3 for every one it goes across. Y is equal to minus 2x. This one is going down 1 for every, down 2 for every one it goes across. Y is equal to minus 1/3 x. This is going down 1 for every 3 it's going across. So these are going through the origin. They all cut at 0. Let's now look at, and we'll take some of these off. We'll get rid of that one, get rid of that one, that one, that one, and that one. This is y is equal to x. If we had y is equal to x plus 1, this is going to be a parallel line. Their gradients are exactly the same, but this one is just going through the point 0, 1. So the first line that we've got on the page is y is equal to x. If you want to think about it as x plus 0, although you wouldn't write it, that's where it's going through. The one that I've just put on is y is equal to x plus 1. So in this case now, the m value is 1 and the c value is going to be 1. Y is equal to mx plus c, gradient of 1, y-intercept of 1. So we can see that straight line, parallel, they're never going to meet. If we did another one, for example now, let's do this one, x plus 2. So y is equal to x plus 2, gradient of 1, and it cuts through the y-axis at 2. So y is equal to x plus 2. Let's do another one. Y is equal to x minus 3, gradient of 1, y-intercept of minus 3. And we can see that in action. Let's put that one on. Okay, so there we go. Nice and straightforward. So gradient of 1 and it cuts at minus 3. Let's go to the other graph, and what we'll do now, we'll have y is equal to 2x. So let's look at some variations of this. This time y is equal to 2x. So what we can see, this has an m value, a gradient of 2, and a c value of 0. So we can see the gradient is 2 over 1. It's going up 2 for every one it goes across. And it's quite clear to see that from here. What we'll do on here now is put y is equal to 2x plus 1. Same gradient, it's just moved up by 1. So in this case what we'd have is y is equal to 2x plus 1. Just consider, that's a gradient, that's where it's cut in the y-axis. These may be written in different forms. If this is written as y is equal to 1 plus 2x, that is exactly the same. Don't get caught up thinking that's the gradient. The gradient is the value in front of the x. So y minus 2x is equal to 1 can be rearranged in the form y is equal to mx plus c. This is ideally the form we want it in to be able to read it. So we'd simply add 2x to both sides. Y is equal to 2x plus 1. Don't get caught out on them. So nice and straightforward. Let's look now at the fractional gradients. If we have now y is equal to 5 over 3x plus 2, this tells me that this is going up by 5 for every 3 it goes across. It's going up by 5 for every 3 it goes across, and it's going through the y-axis at the point 0, 2. This may be written in the form y minus 2 is equal to 5 over 3x. It may be written in the form y minus 5 over 3x is equal to 2. You can always switch that back round into y equals mx plus c. Gradient, it goes up 5 for every 3 it goes across. Let's look at another one. Let's look now at y is equal to minus 1/2 x plus 3. Gradient of minus 1/2. So this is going to go down 1 for every 2 it goes across, and it's going to go through the point now here at 0, 3. So if I wanted to plot this one, now it's going to go through the point here. This is the y-intercept, and this is going to go down 1 for every 2 it goes across. It will go down 1 for every 2 it goes across, down 1 for every 2 it goes across. And you can work your way back up from this way if you think about what's happening. And then all we do is draw a straight line. So nice and logical, nice and straightforward. And remember, this is going to continue right the way across your page. Don't just do one segment of it. And then all we do now is label it. Y is equal to minus 1/2 x plus 3. We can see it's going through here at 0, 3. That's the y-intercept, and it's got a gradient of minus 1/2. If we wanted to do, for example, now y is equal to 1/4 x minus 1. The gradient is 1/4 and it cuts at minus 1. So I'm going to find my point just here. It cuts here at minus 1, and now we've got a gradient of 1/4. So this goes up 1 for every 4 it goes across. It's going up 1 for every 4 it goes across. So all we would do from there is just draw that straight across. Even if you just have those 2 points, you'll be able to draw it. So there we go, that's what it looks like, something like so, give or take. So that one has a gradient of 1/4 or 1/4, and it has a y-intercept of minus 1. And we would simply label this up, y is equal to 1/4 x minus 1. Be aware that this could again be written in many different forms. You might have y plus 1 is equal to 1/4 x. You might have y minus, so you might have, for example, y minus 1/4 x is equal to minus 1. It could be in any form. If you've got really unlucky, you might see it written as 4y plus 4 is equal to x. And that's where we've multiplied through by 4. This comes in later towards the A-level course, but you should recognise that if you want this in the form y equals mx plus c, if you divide through by 4, you'll get that value. So there we go, that's the basic idea. They can be written in different arrangements. So let's look at an example of that. What we're going to have then is 2y is equal to 3x plus 4. So what I want this in the form y is equal to mx plus c. I've got 2y, so I'm going to divide both sides now by 2. So I'm going to end up with y is equal to 3/2x plus 4 divided by 2, which is going to give me 2. So on this one, all I do now is draw this line, and what we'd have now, gradient of 3/2, y-intercept of positive 2. So this one is going to be going up 3 for every 2 it goes across. It'll be going up 3 for every 2 it goes across. So as you can see, I'm going to end up off the screen. Alternatively, we can go back this way, but hopefully if you've got some more graph paper, you can do that. The idea though is changing y over the change in x. It goes up 3 for every 2 it goes across. And let's just put a line through there, and it'll look again roughly, give or take, like so. Just make sure that you're labelling all of these up and continuing drawing them. So y is equal to 3/2x plus 2, or if they wanted it in the original form, 2y is equal to 3x plus 4. Okay, we'll do another one now. What we'll have is the following. We will have 3y minus x is equal to, and we'll go for 9. Okay, so this one, first thing we want to do is add x to both sides. So 3y will be equal to x plus 9. Dividing through by 3, y will be equal to 1/3 x, or x divided by 3 plus 3. So on this one, all we need to do now is find this point here. So we're going to start, and we're going to have the point here. That's where it's cutting the y-axis, and this is going now up 1 for every 3 it goes across. So it's going up 1 for every 3 it's going across, which will be just there, and then we'll go off there. So if you want to come back down the other way, you can do. And again, with time, you'll get comfortable just going back the other way on these. And then what we'll do is draw a straight line through like so. And we would simply label that up. So that's going to be the line. And you might have to put this in the original form. Okay, so let's just put that like so. This one is going to be 3y is equal to x plus 9. Or we could write it as y is equal to 1/3 x plus 3. Okay, so there we go. Nice and straightforward. Really quite not too difficult to get your head around. Let's just look at a couple more of those. What we'll have now is, on the last one we had y is equal to minus x. This would be y is equal to minus x plus 2. So all we've done is move that graph up. Okay, so that's graphing basic straight lines. I always put them in a form y equals mx plus c. M is the gradient. It's a change in y for change in x. It's c is where it cuts the axis. What we now do is look at parallel and perpendicular lines. Parallel lines will always have the same gradient. So for example now, if we had y, let's change that. I keep writing in that pink. It doesn't really work. Y is equal to 2x plus 1 and y is equal to 2x plus 4. These are parallel lines. Their gradients are the same. Wherever you draw those now, they're never going to meet. So for example, this one is going to be 2x plus 1. So let's put that on there. That's going to look, give or take, like so. So let's get it there. And then what we'd have is the following. So we'll do that. That's y is equal to 2x plus 1. So it's got a gradient of 2. It goes up 2 for everyone it goes across, and it goes through a point 1. So now if we wanted 2x plus 4, what we'd see is the following. We'd just get exactly the same line, but it would go through the point 4. Okay, so that's 2x plus 4. And we would continue that, of course, across the graph. If we wanted 2x minus 2, that would be just there. And you can see all of these lines are parallel. They're never going to meet. And we would continue that one up. So we'd ensure that went off our graph paper, like so. So if you're asked to do parallel lines have an equal gradient. So the value in front of the x is going to be the same. Often, though, you might get a hidden parallel line. So y minus 2x is equal to 3, and then y is equal to 5 plus 2x. Those are now parallel lines. They might not look it, but if you rearrange them into the form y is equal to mx plus c, the top one, add in 2x to both sides, and then just rewriting the bottom one, you can see now that the gradients are the same. So they're parallel lines. Perpendicular lines. Let's look at some perpendicular lines. Right, let's grab one of these up. What I've got now, I'll put some perpendicular lines on. We're going to start with the line y is equal to 2x. In fact, we'll start with y is equal to x. Let's make it a bit easier. Y is equal to x. This now is y is equal to minus x. This is a perpendicular line. Perpendicular lines are at 90-degree right angles. So y is equal to x and y is equal to minus x are perpendicular lines. Let's now look at y is equal to 2x. The line perpendicular to that is y is equal to minus 1/2 x. And again, I've only put these through the origin. In general, what we can say about perpendicular lines are at 90-degree right angles. And the notation we can use is as follows. That's deemed to be a perpendicular line. That actually looks quite straight. M1 multiplied by M2 must be equal to minus 1. Now, let's realise what this is telling me. The gradient of the first line multiplied by the gradient of the second line must be equal to minus 1. So let's just look at what I had. I had a gradient of 2 and I had a gradient of minus 1/2. So if I multiply these two, quite clearly, and if you want to write that like so, you'll see that we're going to get minus 1. With y is equal to x, so when we did y is equal to x and y is equal to minus x, we had a gradient of 1 multiplied by minus 1, which of course gives us minus 1. In an exam, you will generally be expected to show this. This tells us that the two lines are perpendicular. The way I like to think about it is it's the negative reciprocal. So if m1 was equal to 3, then m2 would be equal to minus 1/3. All we do is turn the fraction upside down and multiply through by minus 1. So if my gradient of the first line was 2/5, then now the perpendicular line will have a gradient of -5/2. If it was y, if the gradient now, let's put the gradient rather than the line, we'll do some lines shortly. If the gradient on here, m1 of a line, so these are two different lines. Gradient of the first line was going to be equal to -4, then m2 will be equal to +1/4. So let's look at a couple of perpendicular lines. So a typical example, we could say now y is equal to 2x plus 4 will be perpendicular to y is equal to -1/2 x plus 3. Okay, we can see that these lines are going to be perpendicular. If I draw them now, y is equal to 2x plus 4. This is going to give me now something looking like so. Let's graph it up. So here's 2x plus 4. Okay, that's y is equal to 2x plus 4. Now, -1/2 x plus 3 is going to look something like so. So what we're going to get is the following. Let's graph this through. It'll look something like that. Okay, and I'll try and make this accurate. And that's going to be that line. You can see now that they are at 90-degree right angles. These are perpendicular lines. As their gradients, if I multiply 2 by -1/2, I would get -1. Just be careful. If this was line 1, and then we had another line, and that line was y plus 1/2 x is equal to 3, just think, can I rearrange that in the form y equals mx plus c and evaluate their gradients? What we're trying to look at is m versus m. So if we can get them both in the form y equals mx plus c, we can do that. If they were really crafty, you might have something like 2y plus x is equal to 6, and you'd be asked if that is a perpendicular line now to that one. And it is, because if we rearrange it, we're going to have the same form. So they're perpendicular lines. Nice and straightforward. It should really make an awful lot of sense if you think about it hard enough. I'm not suggesting it's intuitive as such, but if you think, it should make some sense. Okay, what we'll do now is look. Sometimes you'll be asked to find the points of intersection of two lines. This sort of goes further into A level, but we can look at a basic example. Say we had y is equal to, let's do 3 minus x, and we had y is equal to 2 plus x. We could find the points of intersection both algebraically and graphically. So if we think about this algebraically, if y is equal to 3 minus x and y is equal to 2 plus x, then 3 minus x must be equal to 2 plus x. So adding an x to both sides and subtracting the 2, 1 is going to be equal to 2x. And then what we'd do from here is simply now divide through by the 2, and we'd end up now with, what's that going to give us? 1/2 is equal to x. Okay. If we drew these, though, we could draw these straight lines. Okay, let's draw the first one. Let's call this one line 1, and this is going to be 3 minus x. Now think about this as a straight line. Let's just rewrite this as a straight line. That line, and we'll call this one line 1, y is equal to minus x plus 3. So gradient of -1, y-intercept to 3. So let's put that on there, and that'll be like somewhere like, I think like so. Let's just move that into place. Okay, and it will do something like this. I will get it to work. It will behave. Well, I say it will behave. I'll just make a better job of doing this. Right. There we go. Is that looking any better? I don't know. No, it's not really. Okay, it will work. There we go. I think well, let's pretend that at least is meant to be accurate. Now, the next one, what we got is y is equal to 2 plus x. So I'm kind of, as I go on through these videos, I kind of start getting a little tired, and I'm not a happy man with technology. Y is equal to x plus 2. So let's draw that straight line. What we'll see now is if we draw that one, this one will behave. Y is equal to x plus 2, which is going to look, give or take, like so. So let's put that on just there. And that will look, and we will continue that one. y is equal to x plus 2, and it will continue up there, and then what we'll have down here is that point here. So what we can now see, assume I'm going to have to do that, it's just annoying me. There we go. Right, if we look now, the point of intersection is where x is equal to 1/2. So if I jotted a line up here, what we can see now is that the point of intersection is going to be equal to 1/2, and that's just there. So we can see both algebraically and graphically we can solve this. Now, of course, if you wanted to solve for y now, what you'd do is simply sub back in x. So with the pink pen, I appreciate that looks a nightmare. If we think 3 minus half is going to give us 2.5, which is just going to be there. So often you'll be asked to do things like this, and you can do a few nice little things with it. You might even be asked to, for example, find the area of a triangle. So if you wanted to find the area of a triangle, you could look now. If they said find the area of a triangle trapped by these two lines in the x-axis, this has got a height of 2.5 and it's got a base of 5. So all we would do is 5 multiplied by 2.5, and then we'd need to multiply this by half, and that would give us now the area of this triangle right here. But that's kind of moving it on a lot more. Okay, I think I'm done. I'm running out of ideas, time, and well, quality, but hopefully you've now appreciated pretty much what you'll be asked to do in terms of straight line equations. The take-home message really is, if you can put it in the form y equals mx plus c, do so. Have a look at the gradient, have a look at the y-intercept, and then draw it from there.